So we learned in previous videos how to convert a vector from magnitude direction form to component form. What about going in the opposite direction? What if you want to convert from component form to magnitude and direction form? The procedure is exactly the same. It's just the opposite. Just like when you convert to component form, the main idea is you're going to be drawing a right triangle and then filling in the missing pieces of the triangle. So it's just that simple. So here's a good example I have on the screen here. We have a vector whose components are x equals -7 meters and y equals 4 meters. What's the magnitude and direction of this vector? All right, so first thing we should probably do is start with a coordinate system. So let me draw an XY coordinate system here. And this is the standard. Whenever I draw coordinate systems, unless noted otherwise, it's the standard XY coordinate system. So X is going to be this way and Y is going to be this way. Sometimes I forget to write it. Okay, so just like I explained in previous video, there are actually two ways to draw this triangle. You can do X first and then Y, or you could do Y first and then X, and that will give you the same answer either way. The natural way to do it is probably to start with X because that's the one that's given first. So what we want to do here is construct a triangle, start at the origin, and first I want to go X equals -7. So that means I'm going to go in this direction by 7 meters. And then I want to go Y equals +4. So that means I'm going to go up in that direction. Okay. So this side here is 7. And by the way, I'm not saying that that side has length -7 because the negative sign has already been taken into account in the fact that I made that line go left instead of right. So that will all work itself out later. The length of that side is 7. So this is the opposite of, putting in the negative sign yourself. You also have to take it out yourself there, at least the way I do it. So there's 7 and 4. Now the next thing we do is draw in the hypotenuse of the vector. So the hypotenuse is the vector that starts from the origin and ends up at that point that we just found using the X and Y components. So as you can see, I now have a triangle. Let's solve the triangle. So the hypotenuse of this triangle is going to be the magnitude of the vector. What should we call this vector? How about vector? We'll call it vector D because it's some kind of distance or just distance isn't a vector, but it's some kind of displacement or something like that. So I'm going to call it D. And the hypotenuse of the triangle here, this is going to be magnitude of D. And I'm going to need to define an angle. So I'm going to solve for this angle here. We'll worry about how this relates to counterclockwise from the positive x-axis and all that junk later on. First, I need to just find an angle. So now I have a triangle drawn. Now I need to construct some equations. So let's start with, how about tangent? Why don't we start with tangent in this case? Because the two sides that are given are opposite and adjacent. So if I pick sine or cosine, I'm going to have a little bit of a problem because I'm going to have two unknowns. So let's start with the tangent formula. So tangent theta is opposite over adjacent. Opposite is going to be 4 because that's the one that's opposite of theta, and adjacent is going to be 7. So tangent theta equals 4 over 7, and you invert that simply by taking inverse tangent, also known as arctangent, of both sides. So we're going to have inverse tangent of 4 over 7. On your calculator, you can normally do inverse tangent as the second function of tangent typically. Like this is my old calculator. You can see above the tangent key, the second function of it is tan -1. So that's the inverse tangent. So I'm just going to do 4 divided by 7, and then do second function inverse tangent, and it gives me 29.7 degrees. So there's my angle. Now, the other thing I need is the hypotenuse of the triangle. Easiest way to get it is probably using Pythagorean theorem in this case. So the magnitude of vector D is equal to square root of 4 squared plus 7 squared. And that is 4 squared plus 7 squared equals square root 8.06. Okay. So the magnitude of this vector is 8.06 meters. Magnitude is always positive, remember, so that is just done. Magnitude is 8.06 meters, period. And the angle of this vector I do need to be a little bit careful about. In a question like this particular one, they haven't really given you any guidance about how the angle should get specified. They've kind of left it up to you. So the easiest way to answer this question would probably be to say that, let me kind of type it out in words just to show you. So you could say, you know, the direction of this vector is 29.7 degrees. This would be clockwise from the minus x-axis. That would be one way to say it, because that's the actual angle that I solved for, is the one that goes clockwise starting at the negative x-axis. By the way, I've already, in the short time that I've been making these videos already, said this about half a dozen times. I'm going to say it again. This is why it's really important to draw the picture. Because if you haven't drawn, like I can't tell you how many times I've seen this on tests and stuff like that. I give someone a question like this, they don't draw the picture at all. They just start calculating. And then they solve for theta equals 29.7 degrees. And they say, you know, done, I've solved it. And their answer is the direction of this vector is 29.7 degrees. What are you talking about? 29.7 degrees isn't a direction. Again, go back to like asking somebody for directions at the beginning of the course. How do I get there from here? Oh, no problem. Go 8 miles, 30 degrees. They're going to say, what the heck are you talking about? That doesn't make any sense. I can't find it with these directions. 30 degrees from what? You know, and you have to say 30 degrees from this direction. So in this case, I have a picture there. I look at the picture and I say, aha, the angle that I chose to calculate is 30 degrees clockwise from the negative x-axis. Or if you wanted to do this in the standard method, where you go counterclockwise from the positive x-axis, you would be measuring this angle. Oh, that's not what I meant to do, but get it? Okay, now it's going to turn my color back. Great. Okay. This would be the standard angle to measure. So let's call it, I don't know, let's call it phi. So this angle here, I can see from a little quick geometry, this would be 180 minus theta. So that would be 150.3. So another way to specify the direction then, the standard kind of method would be to say the direction is 150.3 degrees counterclockwise from the plus x-axis. And both of those two statements are true. Both of those, in terms of how this question is asked, both of those would be correct answers. So you may have to make adjustments like that depending on how the question is asked. It might ask you to measure the angle in a particular way. Otherwise, you just have to say how you measured it. But overall, it's the same idea as how you do other switching between representation type problems. You set it up as a right triangle and then solve the right triangle.